What if I told you that an interstellar visitor just shattered everything we thought we knew about cometary physics? Imagine a comet, or what appears to be a comet, growing a tail that points straight at the sun instead of away from it, and yet NASA holds a press conference, acting like nothing unusual happened. Right now, while you're watching this, something extraordinary is unfolding in our solar system. The Hubble Space Telescope has captured images of an object called 3 Atlas, and what astronomers are seeing has sent shockwaves through the scientific community. The findings defy the fundamental laws of how objects behave in space, and what you're about to hear will challenge everything you thought you knew about our cosmic neighborhood. For over a century, scientists have understood comets. When a comet nears the sun, solar wind pushes gas away from its nucleus, while radiation pressure drives dust in the same outward direction. This process creates the comet's iconic tail, a glowing streak that always points away from the sun. Every comet ever observed has followed this rule, like clockwork. Until now, 3 Atlas did not follow this cosmic memo. On July 21st, 2025, Hubble captured detailed images of this interstellar visitor, revealing something baffling. The glowing halo surrounding it stretched further in one direction than expected. Initially, astronomers thought it might be a standard dust cloud or a typical outgassing event, but closer inspection revealed the impossible. The tail was pointing directly toward the sun. Not slightly, not approximately, but a massive jet of material streaming in the exact opposite direction of every cometary tail ever recorded. It gets even stranger. At the time of observation, the viewing angle was only 10 degrees from the sunward direction. Once corrected for perspective, the jet wasn't just elongated, it was 11.6 times longer than it was wide. A tightly focused column of material, shooting like a cosmic finger straight at our star. Skeptics argued it could be an optical illusion, a projection effect making a regular tail appear sunward. But on January 7, 2026, Hubble captured new images from a completely different angle, and the anti-tail was still there, now even more prominent. This wasn't an illusion. The material extended nearly 400,000 kilometers from the nucleus, roughly the distance from Earth to the Moon, streaming toward the Sun and defying everything we know about solar system physics. But that was only the beginning. When researchers applied a rotational gradient filter to the images, removing the circular glow around the nucleus, they discovered not one jet, but 3. A triple jet system with a major anti-tail pointing at the sun, and 2 minor jets angled in ways that violate conventional cometary physics. Solar wind should have obliterated any sunward motion. The sun's radiation pushes on every particle, and yet this jet punches straight through it, as if the pressure doesn't exist. What kind of force could maintain a material beam against the combined output of the sun? Could it be natural? Could it be chemistry, ice composition, or spinning dynamics we've never seen before? Scientists like Dr. Avi Low of Harvard tried to explain it, even submitting papers to top journals. Some journals refused to review the work, deeming it of limited interest, despite its unprecedented implications. This raises a troubling question about how science sometimes handles anomalies. The anti-tail is real. The rotation axis alignment is real. The trajectory aligned with the ecliptic plane is real. Each anomaly alone might be explainable. Together, they paint a picture of an object that simply does not behave like any comet we've known. Yet, the institutional response has largely been to downplay or dismiss these findings. Science is meant to follow the evidence wherever it leads, even when it makes us uncomfortable. Ignoring anomalies to maintain the status quo is not science, it's convenient. As Dr. Low pointed out, the easiest way to claim complete understanding is to ignore what we don't understand. And that's exactly what seems to be happening with 3 Atlas. But the universe doesn't care about our expectations. It simply is. And that's what makes discoveries like this so exciting. The anomalies of 3 Atlas demand our attention. And for those willing to look, they offer a glimpse into phenomena that challenge our deepest assumptions about reality. Now, Let's dive deeper into why the anti-tail of 3 Atlas is so utterly baffling. To understand the impossibility, we need to revisit how comets normally behave. As a typical comet approaches the Sun, the heat begins to sublimate the ices on its surface: water, ice, carbon dioxide, carbon monoxide, and other frozen gases, turning them directly from solid to gas. This process, called outgassing, carries dust particles away with the gas, forming the coma, the fuzzy halo surrounding the comet's nucleus. So far, everything seems normal. But then comes the solar wind. Our Sun constantly emits a stream of charged particles, protons and electrons, racing outward at hundreds of kilometers per second. When these collide with the gases in a comet's coma, they push everything directly away from the Sun. Solar radiation pressure works on the dust particles the same way. The result? The classic comet tail, always pointing away from the Sun. Most comets even have 2 tails, a blue ion tail formed by charged gas, and a white or yellow dust tail that curves slightly due to the comet's motion. Both always obey the same rule: away from the Sun. 3 Atlas defies all of this. Its anti-tail points directly toward the Sun and stays coherent over hundreds of thousands of kilometers. Unlike typical jets, which disperse rapidly once they leave the nucleus, the anti-tail of 3 Atlas behaves like a laser beam, maintaining tight collimation across nearly 400,000 kilometers, the distance from Earth to the Moon. To accomplish this, the source must be incredibly powerful and extremely precise, continuously feeding the jet with material moving fast enough to overcome the relentless push of the solar wind and radiation pressure. Scientists have proposed possible natural explanations. Maybe 3 Atlas contains exotic ices that behave differently than water ice. Maybe the nucleus has an unusual internal structure that channels the material into a tightly focused stream. Some suggest magnetic fields might play a role, though comets aren't known to carry strong magnetic signatures. And yet, none of these hypotheses fully explain what we're observing. The physics just doesn't add up. This leads to a provocative question. What if 3 Atlas isn't natural at all? What if the anomalies, the anti-tail, the triple jet system, the perfectly aligned rotation axis aren't the result of ice chemistry or unusual geology, but of technology? I'm not claiming 3 Atlas is an alien spacecraft, not yet. The evidence isn't strong enough to support that. But consider the context. The galaxy has over 200 billion stars, many older than our Sun. Intelligent civilizations could have arisen millions or billions of years before humanity even existed. The idea that we might encounter technological artifacts from such civilizations is not science fiction, it's statistical probability. The question isn't whether it's possible, it's whether we would recognize it when we saw it. And the way we respond to anomalies tells us a lot about our readiness. If our default is to dismiss irregularities as of limited interest, then we might miss the one observation that could change human history. That's what happened with Oumuamua, the first known interstellar object, which exhibited strange accelerations that were never fully explained before the community moved on. Now, 3 Atlas presents a new set of anomalies, and history could repeat itself. Here's the most striking part. When 3 Atlas entered our solar system, its trajectory was almost perfectly aligned with the ecliptic plane, the flat disk where all planets orbit. Statistically, an interstellar object should approach from any direction, yet this one is cruising directly along the cosmic highway of our solar system. The odds of such alignment are already extremely low. And remember the anti-tail pointing at the Sun? Tracking its wobble revealed that the object's rotation axis is aligned to within 7 degrees of the Sun. 2 independent alignments, both astronomically improbable. Combined, the odds drop below 1 in 100,000. And yet, when NASA held its press conference on November 19, 2025, they concluded everything was normal. No mention of the trajectory alignment, no mention of the rotation axis, no mention of the anti-tail defying fundamental physics. Perhaps they wanted to avoid public confusion. Perhaps they were waiting for more data. But science is about following evidence, even when it makes us uncomfortable. Ignoring anomalies for convenience is not science. Dr. Lowe put it best. The foundation of science is humility to learn, not the arrogance of expertise. Our ability to understand the universe is limited by what we are willing to admit we don't know. And right now, when it comes to 3 Atlas, there is a lot we don't know. The anti-tail jet, the rotation axis alignment, the trajectory, the triple jet structure. Individually, these might have explanations. Together, they paint a picture of an object unlike anything we've ever seen. So here's the challenge. Will the next generation of scientists rise to the occasion? Will young astronomers look at 3 Atlas without preconceptions, unburdened by institutional conservatism? Because whether 3 Atlas turns out to be natural or extraordinary, studying it teaches us something valuable. Either we expand our understanding of cometary physics, or we witness something unprecedented, potential evidence of technology beyond Earth. Either way, science advances. The only way we lose is if we refuse to look. As we move deeper into the mystery, the implications of 3 Atlas become even more staggering. Consider the fairy paradox, a thought experiment often discussed in astrobiology. It asks, if advanced civilizations are common in the galaxy, why haven't we seen any clear evidence of them yet? The paradox forces us to question everything we assume about life, intelligence, and technology. 3 Atlas doesn't answer the paradox, but it brings it to life. Here is an object that, by all ordinary measures, shouldn't exist, yet it's here, in our solar system, behaving in ways that defy conventional physics. History is full of anomalies that were ignored or dismissed, only to later revolutionize science. Think of the discovery of pulsars in 1967. Initially, the first signals were thought to be interference, even jokingly called LGM, for little green men. Then, careful observation revealed a new class of astrophysical object, one that no one had predicted but which fundamentally changed our understanding of stellar evolution. 3 Atlas could be the next pulsar moment. Not a signal from aliens necessarily, but a profound challenge to what we thought we knew, and the more you study it, the stranger it gets. Its triple jet system isn't just random. Each jet erupts in a precise pattern, synchronized to the rotation of the nucleus. Normally, jets from a comet are chaotic, driven by local ice pockets heating unevenly, but here the jets maintain an exact cadence, almost like a mechanical heartbeat. It's as if some internal mechanism is regulating the outflow, an engineering solution to a natural problem, or an engineered phenomenon masquerading as nature. Then there's the question of durability. Cometary material is fragile. Solar radiation and the constant bombardment of micrometeoroids should tear it apart over thousands of kilometers. Yet the anti-tail remains intact, a narrow column of dust and gas stretching 500,000 kilometers without dissipating. That alone challenges every model of comet physics. To preserve a structure like that, the forces at play must be perfectly balanced. The precision is uncanny, bordering on deliberate. Even more provocative is the timing of its arrival. 3 Atlas entered the inner solar system just as humanity is at the peak of observational technology. Space telescopes, deep space probes, and all-sky surveys are more advanced than ever. If an object like this had passed 50 years ago, we might have never detected it. Now, it's visible in exquisite detail. The universe has presented us with a cosmic puzzle. At the exact moment we have the tools to study it. That in itself feels almost intentional. And while we debate whether the object is natural or engineered, one fact is undeniable. It forces us to reconsider assumptions. What is the limit of cometary physics? How precise can natural systems become under extreme conditions? How rare is a trajectory so perfectly aligned with planetary planes? And most importantly, what does it take for us to accept that some phenomena might exceed our current scientific framework? 3 Atlas challenges the human imagination. It's a reminder that the universe is bigger, stranger, and far more precise than we often give it credit for. Whether it's a natural anomaly or a technological artifact, it teaches us humility and curiosity, the 2 pillars of discovery. Every time we think we've seen everything, objects like this come along, reminding us that the cosmos has surprises, some subtle, some blatant, and some that seem to wink at our very assumptions about reality. So, as we track its path, measure its anti-tail, and analyze its jets, we must keep an open mind. Not everything that defies explanation is evidence of intelligence, but not everything that seems impossible is beyond comprehension either. 3 Atlas may ultimately reveal new laws of physics, new cosmic mechanisms, or perhaps new windows into the potential reach of advanced civilizations. One thing is certain: humanity is watching a once-in-a-lifetime spectacle, and the lessons we learn could shape our understanding of the universe for decades to come. As we reach the climax of this story, it becomes clear that 3 Atlas is not just a comet, it's a wake-up call. It's a reminder that the universe is far more complex and surprising than our models, our instruments, or even our imagination can fully capture. Every anomalous jet, every precise alignment, every columnated anti-tail stretching toward the sun is a signal to scientists and to all of us that there's still so much we don't understand. Think about what this means for the future of astronomy. Young astronomers entering the field now have an unprecedented opportunity. They can observe phenomena that challenge conventional physics, question assumptions that have gone untested for decades, and push the boundaries of our understanding. They can be the ones to finally crack the mystery of 3 Atlas, to figure out whether it is natural, engineered, or something entirely unexpected. And that is the real beauty of science. It doesn't require us to have all the answers up front. It thrives on questions. Every time an observation contradicts expectations, every time an anomaly refuses to fit into existing frameworks, science grows stronger. 3 Atlas is a rare cosmic gift, giving us not just data, but an opportunity to expand our horizons. So, what should we take away from this? First, we must watch closely and investigate fully, ignoring anomalies, dismissing unusual findings as of limited interest, or assuming that everything must fit known models only slows progress. Second, we must remain humble in the face of the cosmos. The universe does not conform to our expectations, we conform to its reality. And third, we must remain curious. Whether 3 Atlas turns out to be a natural marvel, a technological artifact, or something we cannot yet comprehend, the act of investigation itself is a triumph of human curiosity and ingenuity. In the end, 3 Atlas is more than an interstellar visitor. It's a mirror, reflecting our own readiness or unreadiness to confront the unknown. And perhaps it's a test, a cosmic question posed to humanity. Will we rise to the challenge, observe carefully, and learn? Or will we dismiss the signs, content to maintain the illusion of certainty? The universe is whispering secrets, and right now, 3 Atlas is one of its loudest voices. It reminds us that science is not a static collection of facts, but a living, breathing pursuit of understanding. It asks us to embrace the strange, the improbable, and the inexplicable. It asks us to look, really look, without prejudice or fear of being wrong. Because the moment we refuse to look is the moment we stop discovering. And if we let that happen, the universe keeps its secrets, and we remain mere spectators. But if we pay attention, if we follow the anomalies wherever they lead, then the story of 3 Atlas could mark the beginning of a new era in our understanding of the cosmos, an era where the extraordinary is not ignored, but studied, embraced, and ultimately understood. So stay curious, stay observant, and keep watching the skies. 3 Atlas has arrived, and it has a story to tell. Will we listen?